Okay. All right. Hi, guys. My name is Prashant. I am part of the OWASP Bay Area chapter. Good morning, everybody, and good evening to the people from the other parts of the world. I'm sure a lot of people would have joined us from other different countries. I hope you're staying safe, wearing mask, washing your hands. So right now we are glad to have Serge on this for this session. App Consensus have been big supporter of OWASP. They have supported us in various events. I'm sure you guys would love this session. So over to you, Serge. You can get started. Thank you. You're on mute, Serge.
Yeah, thanks for the introduction. Let me share my screen. Okay. Okay, great. Thanks for the introduction. I'm Serge Egelman, and I have 3 jobs. For the past about 10 years, I've been working at the International Computer Science Institute, which is a research institute affiliated with UC Berkeley. And from that, I've spun off a startup, AppCensus. My research has been focused on looking at privacy of mobile apps. And so this talk is sort of the summation of things we've learned over the past 10 years or so and implications for practitioners, and how actually a lot of the bad privacy behaviors that we observe is due to misconfigured SDKs. So I was going to talk about some of the tools that we've built to study these problems, and how we've been using those now to study compliance generally, and then go into some SDKs that we've seen and what this actually means. So for your organization, how you can try and avoid some of the issues that I'm going to identify. So in the beginning was the word, and the word was permissions. So 10 years ago, when I first started looking at mobile privacy and mobile security generally, everyone at that time was pretty much just looking at app permissions. So on Android, you had these dialogues which told users what types of data an app might have access to. And so we did some studies early on to see whether users understand these. So we published a paper, this was published in 2012 now, and what we found was that, from conducting an online survey of 300 some Android users who we actually showed these dialogues to, very few of them really understood what they meant and what that allowed apps to do. We brought people into the lab as well, where we observed them install apps on their phones, and basically, concluded that having install time permission requests don't really work because people don't notice them, and they're not written clearly enough for people to understand them, even if they were to notice them. And so the platforms have evolved since then. So now for communicating privacy, we have these runtime notifications. And in fact, Apple has now announced that they're going to start doing these nutrition labels now. And while this is all a great improvement and still is more likely to help people exert control over their private information, as well as to help apps meet their compliance obligations, there's still a shortcoming in that it doesn't really identify how data is used, and that's one of the fundamental concepts that a lot of consumers want to know about. So, there are a bunch of open source tools out there that, provide some privacy, information about mobile apps. And I don't mean to pick on Exodus in particular, but it's one of the, the most popular open source tools for this. And, it lists things in terms of trackers and permissions, and this is all static analysis. So the permissions, it basically shows you a list of data types that the app might be able to request. But again, the shortcoming is none of this tells you what actually happens at runtime, much less who's receiving that data and what you can do about it. And so I get this question a lot, both from developers who are trying to do better, as well as regulators who are trying to find bad actors, and consumers. Everyone wants to know, how can you identify good privacy practices in apps? And so my standard answer is, well, just do what we do, which is instrument the permission protected APIs, disassemble the app binaries, and then perform deep packet inspection. This is obviously a joke, but I contend that really this is what's necessary to understand the privacy practices of mobile apps, just because it's an incredibly complex ecosystem. But instead, what consumers and everyone else is left with is the notice and consent framework, which basically means read privacy policies if you're a consumer, or if you're a regulator, or if you're a developer, reading privacy policies, as well as lots of SDK documentation to understand, and terms of service to understand whether the third-party code is going to collect the data that you think it's going to collect. And so let's take a look at how this works from the consumer standpoint. If you want to download an app from say the Play Store, you pick an app, and then you need to know to scroll to the bottom to read that privacy policy, and read it you will. It's fairly lengthy. In fact, this one would take significant time. And if imagine having to do this for every single app. So this is over 5,000 words. It's written at it requires a high school education to read it, and therefore based on the word level and reading level, it would probably take the average consumer more than 20 minutes. Imagine doing that for every single app that you're considering installing. That's obviously unreasonable. And so, this isn't a new issue. Privacy policies have been well studied. So, more than 10 years ago now, some colleagues did this experiment looking at websites where they looked at the average reading rate, and the median policy in terms of the word complexity and the length, and found that the average consumer would spend 200 hours a year reading privacy policies if they were to read all of the privacy policies of all the websites they visit. No doubt that's probably increased in the past decade. And so, none of this also, gets at the question of what about third parties, which is often the question that people want answered, right? So if I install this app, who is the data going to be shared with? And so, the way the notice and consent framework is set up is that the app privacy policies will say data is going to be shared with third parties, and then it's up to the consumer to look at the privacy policies of those third parties to decide whether or not they're agreeable. The problem is when you look at a privacy policy, it'll say that data is shared with entities such as business partners or advertisers and service providers, but doesn't actually name anyone because there are no obligations to. And so what that means is there's no way of getting from A to B. Which is why I contend that unless you're decompiling the app or inspecting network traffic, there's not really a way of answering this question. And so I'm going to talk about how we're doing some of this to answer it. And why it's important, because making sure that in many cases, if you're offering a product for consumers that's either available to consumers in California or available to consumers in the EU, you're legally mandated to have a privacy policy. So starting in 2000 under the Children's Online Privacy Protection Act, if your app was app or service is directed to children, you need to have a privacy policy. In 2004, CalAPA was enacted, which required that privacy policies be posted if you have consumers located in California. 2018 was GDPR, which required privacy policies if you have if your consumers are in the EU, and CCPA now makes it double plus legal to have a privacy policy. And so, making sure that these are accurate is important because that's another compliance obligation. And so we've been looking at this at scale over the past couple of years now. I think since about 2016, 2015, when we started looking at mobile apps to see whether or not their privacy policies actually match what their behaviors are and whether those actually comply with the relevant laws and regulations. And so to do this, we combined two different tools that were going on at the Institute. So my lab had been working on a version of Android that we had instrumented. Basically, we had modified the kernel to look at what files are being opened and what executables are being run, as well as instrumenting other layers within the Android OS. So that we can intercept permissions. So for instance, whenever an app tried to access the GPS location, we can log that. We then combined that with another tool that was being developed at the Institute, Lumen, which was previously called Haystack. It's a user space network monitor. And basically the way that it works is using the VPN interface. It does TLS interception. And so combining these tools, we built a pipeline so that we can download apps, run them to observe the data flows, and then detect what personal information was being exfiltrated. Actually, Erwin Reyes is here at this talk. So I hired him around that time as a research programmer at ICSI, and he basically strung the, built the whole system that strung together the instrumented OS, the network monitoring tools, and made it into a end-to-end pipeline. And so starting, I guess this was around 2016, his office started slowly turning into a click farm where we had lots of phones running our customized operating system, and then had a computer that was pulling all of the logs off and analyzing them to look for personal information. So we can scan the traffic, in addition to collecting the instrumentation about the logs from the instrumentation about what data was actually accessed on the device by the executable. We can then see what API endpoints were contacted and what types of personal information they received, such as the email address associated with the device, location coordinates, various persistent identifiers, and so forth. Since we know the values of all of these a priori, it's pretty easy to then scan traffic for them. So we built this end-to-end test bed where we start pulling apps, run them on our phones, and then put the results into a database. And that's all accessible now by API and on a website. So to give you an example of just what this looks like in terms of running an app to see what it does, we can enter a package name, specify a country we want it tested in, because one behavior that we see that's pretty common is if you have an app that's for global distribution, you're obviously going to have different requirements in different countries, such as whether you provide GDPR treatment only for people who are located in Europe, or if you're going to do it for everyone. And often we see that apps are doing things like using GeoIP information to decide whether or not at runtime they should provide the GDPR treatment. And so that's why we found it important to have phones in different countries, physical hardware there that we can just push tests to, because behaviors do differ. And sometimes, again, developers, as I'm going to point out, throughout this talk, it's often the case that developers might not even be aware that their own apps are behaving differently because of third-party code. So anyway, we can specify, whether a human does the testing, and what that means is, then the phone, gets the app that we want to test, and we have a remote desktop solution that opens up in the browser, and so from the browser you can interact with apps and basically play apps in phones located all over the world. And then at the end, data gets pulled off, and we get summary statistics and then richer data on what actually happened, such as where different API endpoints were located, whether transmissions to those those endpoints contained known identifiers, and so forth. So for instance, in this case, we see that the only identifier was the Android ad ID, and that was transmitted to DoubleClick. We also do some SDK identification, but again, the shortcoming of only doing the static analysis is that not all of these are necessarily going to be run at runtime. Some of it might be dead code, some of it might be misidentified, since this is, identifying SDKs is very much an open research problem right now. But that combined with looking at where the API endpoints are gives us a good understanding of what's happening. And so let's take a look at what this actually looks like. So early on, when we first built the system, we were testing apps round the clock on all of our phones so that we could just build up a database of behaviors, so that we can run queries such as show me all of the apps that transmit location coordinates to third parties, for instance. And one query we ran was just to look at what apps are sending the most location data. So, in this case, I did this and we saw that there were 40 different third parties that were receiving location data from CVS. And looking in the traffic, then we found what was happening, which was that the user agent string, whoever wrote the app was putting, so the app was built on several, it's basically a bunch of web views that the whole app just loads content from the CVS website. And, so it uses the web view component, which is a widget that basically creates a lightweight browser on the device. And the user agent string, someone, whoever wrote this, was putting the location coordinates into the user agent string, which means that any third-party content that appeared on those websites, those third parties were also receiving the user agent string in the headers. And so location data really was going to all of them, though it's likely they weren't expecting it. And so, in fact, I contacted CVS, and actually, I think this is also another anecdote which might be of interest to many on the importance of having a technical contact information listed on your website. I spent about an hour trying to find someone at CVS to point this bug to, and having given up, I contacted customer care, who of course said that oh no, they don't share location data with anyone, not understanding the problem. And so, being out of options, I went to journalists, and CNET covered it. The appropriate people at CVS found out, and it was fixed, in a week. And in fact, what had happened was, exactly what happened. What it looked like was, they actually outsourced the development of the app to some third-party contractor who, for whatever reason, built a bunch of web views and were passing location coordinates. And so, CVS as a company actually didn't have any idea this was happening because it was some third party that, that did this on their behalf. Nonetheless, CVS wrote their privacy policy, which said that they don't share location data, which wasn't technically accurate here, even though they probably, up until this moment thought it was. And so, the point is that, software is complex, and so developers are often simply unaware of the privacy issues in their own apps because they're often using third-party components, which, don't get me wrong, I'm not, the takeaway from this talk shouldn't be that, code reuse is bad. But that when, the real takeaway is, when you do code reuse, you take on certain responsibilities for someone else's code. And this, in some cases can create actual legal liabilities for you. So, I briefly alluded to COPPA, the US Children's Online Privacy Protection Act. This provides protections for children under 13. It makes it illegal to collect personal information from them for behavioral advertising or profiling purposes. Certain data that's collected, requires parental consent, and the data needs to be transmitted with reasonable security measures, which is the wording of the law, which, in this day and age, we interpret to mean that, using TLS at a minimum. And so we started looking at this, since this is one of the few, privacy laws in the US that in existence. We wanted to see how well, the companies are actually complying with this. So we started collecting children's apps. So here's an example of one developed by Baby Bus Kids Games. And we looked at the traffic, and we see, in yellow here, there's data going to port 80, so unencrypted, to talkingdata.net, which is a analytics and advertising company. In blue, it lists pretty much all the persistent identifiers that are associated with the device. So not just the ad ID, but also the serial number, the Android ID, the IMEI. And then in green, it lists not just the access point that we are currently connected to, so both the SSID and the BSSID of the Wi-Fi access point, but it also lists those of prior ones as well. And in fact, this developer, it wasn't their first brush with COPPA. It turns out that actually about 2 years before we discovered this, the FTC had written them a sternly worded letter about their COPPA obligations. But nonetheless, due to the inclusion of this third party, they appear to be violating it. And we started studying this at scale by downloading thousands of apps. So we were able to collect almost 6,000 apps that were marked as targeted at children. And the conclusion that we came to is that the majority of them appeared to be in violation in some way or another. So, in cases of, outright collecting personal information that's, strictly illegal, like location data going to advertisers, that was relatively rarer. So that was, a little under 5%. Most of it was data that was going to either non-compliant services, such as services that are, going to explicitly use that data for behavioral advertising or profiling purposes, not sending the data with TLS encryption, or basically rendering the privacy controls useless by using non-resettable identifiers. And so most of this, as I've been saying since the beginning of this talk, is due to the third-party services. So, we found that also not just the third-party services, but many of the violations that we observed were already, against policy in terms of the Play Store policies. The issue is that they're just not enforced. Google leaves it to developers to ensure that they're complying with both the Play Store policies and the law. And as a result, when developers aren't aware of their obligations or how to correctly follow them, things fall through the cracks. So here's another example. So here's the advertising ID, which exists on Android. So this is by policy, developers are only supposed to collect the advertising ID for profiling and advertising purposes. And that's because the user has the ability to reset it. But in fact, if this ID is sent alongside other non-resettable ones, that basically negates the function of that privacy control. So clicking reset to reset the ad ID is pretty meaningless from a privacy standpoint if other non-resettable identifiers are already associated with that user. And when testing this, we found that 3/4 of the apps that transmitted the ad ID did so alongside other identifiers. Many of these are, ad companies. So Chartboost was doing this almost uniformly. Other companies like Greedy Game and Tapjoy as well were transmitting identifiers like these in violation of the policy. At the other end of the spectrum, you have, DoubleClick at only 1%, which I guess seems good until you realize that that's owned by Google. And it seems a bit surprising that Google's own ad company isn't following Google's stated policies. But, again, it's a complicated problem. A related thing is that, we found that almost 20% were sharing these types of identifiers with third parties that explicitly said that, either don't use this in children's apps, or said that, the data that we collect will be used for behavioral advertising, which, in both cases, this is probably going to be illegal for COPPA purposes. So, a bunch of companies, outright say this in their terms of service: don't use our SDK in children's apps. Here's MoPub. You will not transmit any personal information as defined under COPPA about or relating to an individual under the age of 13 to MoPub. You might wonder why. Well, you look at their, again, in their privacy policy, it says that, the data that they collect is used for interest-based ads, and therefore, if that data comes from children, that's most likely illegal. And so we published this. And that made some waves because I guess a lot of people didn't quite understand the level of non-compliance out there. And in fact, one of the bigger developers that was doing a lot more egregious things got sued along with Google and Twitter as advertisers as part of that were embedded within the app. And so, that was fun. The New York Times sent a photographer who opened up my office door and said, too many plants, not enough blinking lights. So I got to go to the machine room for the first time. It was fun. More importantly, though, about 6 months later, Google actually passed a policy change saying that, as a result of some of this research, they're strengthening protections and in creating more obligations for developers in the process. And so now if you have an app that's targeted towards children, use one of the approved ad networks. Why are these approved? Well, all of these have configuration flags that developers can use to disable behavioral targeting to get them into compliance. And so it's not just COPPA now, it's also CCPA. If you opt out of data collection, then that needs to be honored. And so you need to be sure that the third parties you're sharing data with are honoring that request. The problem here, again, though, is that compliance is entirely self-certified. So, you're supposed to only use apps that come, ad networks from this list because they have options to disable, profiling. But whether or not that option is correctly configured, no one checks for that, which is part of the problem still. And so let's look what that means. So here's some documentation for one. Here's Ad Colony, which, again, if you know to look through the documentation to look this up, you're a step ahead of most. It took me significant time just to find where in their documentation it even talks about this. And so you go to their website, there's a dashboard, and then if your app is targeted at children, you click this box, and then that correctly configures the SDK. You don't, you might be violating federal law. Similar with Chartboost, they have instructions on their website that instructs developers how to do this. Here, Kachava is another one. Here's a segment of code that they instruct developers to paste into their apps to correctly configure their SDK. And so it's easy to see how a lot of developers might miss this documentation and inadvertently misconfigure their apps. So we remeasured this, and we looked about this was about 18 months later. Well, we found that, in fact, now that there's been attention to this issue, both through some of the policy changes at Google, as well as SDKs starting to be a little bit more proactive and make it easier to signal compliance obligations to developers, there's been improvement. So in terms of outright collection of prohibited data, that's decreased to about a third of what we first saw. And similarly with insecure transmissions, but problems still remain. We still see a lot of use of the unapproved ad networks and use of not correctly configuring them to disable tracking correctly. And that's because no one's really looking for this stuff, because that requires in many cases deep packet inspection. And part of the problem is that each SDK simply has its own API. In order to check whether or not your app is correctly sending the correct flags to the correct API endpoint, that requires some knowledge of what those correct flags actually are, and what the range of options for each of those flags is. And so here's an example that we saw early on. So Facebook ads, in their documentation, they tell developers that if if your app is primarily child-directed, don't use Facebook ads altogether. But if children are only part of your audience, you can use an age gate. And so when there are children using it, then you can set this flag. And the result of setting this flag correctly is it sends to Facebook, COPPA equals true, and that tells Facebook to provide COPPA treatment and not use the collected data for behavioral ads. If you don't send this, then the data is used for behavioral ads. And so here's Duolingo, which at the time that we looked at this was listed in the Design for Families program, so targeted at children, but was sending COPPA equals false along with the ad ID. This was being sent to Facebook and therefore was likely being used for targeted advertising. And the reason, once we dug a little closer, is that ad mediation was happening. And so for those unfamiliar, if you're an app developer, you want to maximize your ad revenue in your app. And so rather than just having an account with one ad network, you get accounts with multiple. But then you pay another company who's the mediator that basically picks and chooses from all of these available ad networks to optimize the ad placement. Maybe under some circumstances, one ad network is going to offer a higher price for one placement, and on different circumstances, another one will. And so the mediator takes care of that. The problem is, since the mediator is the one that's talking to the ad networks, the mediator also needs to know which flags to send them. And so in the case of Duolingo, we observed that AdMob was doing ad mediation. So it sat as a layer in between Facebook and Duolingo. And AdMob has documentation that explains how to provide COPPA compliant treatment. We looked at the app, and sure enough, this tag for child-directed treatment function was being called. So we can see that we performed what we call binary archaeology, and we see that those settings were there. The thing that we missed was that, and what appears that the Duolingo developers missed as well, is if you scroll all the way to the bottom of the documentation at the time, it says that actually forwarding these flags on to it doesn't occur when AdMob is in mediation mode. So when AdMob is used as a standalone ad network, you call this function tag for child-directed treatment, and that will signal that the app should be COPPA compliant. except when you're using it in mediation mode and it's contacting other ad networks, then it just doesn't send that flag. And that's why Facebook was inadvertently using the data for behavioral advertising, despite the fact that the Duolingo developers had called this function, which likely they led them to believe that they were in compliance. And so you can see why this is pretty messy. And so the main thing here is that do developers know to look for these documents? So and also do those responsible for compliance. So if you're in a a software organization, you probably have compliance folks who are responsible for making sure that your privacy policy matches what your app does. But those people only know what you tell them. They're probably not running static analysis tools to look at what SDKs were bundled in the app so that they can then go back to you and ask questions about those. They're requiring some sort of disclosure. And similarly, when if you're a developer and you're putting third-party SDKs into your app, if you miss pieces of the documentation, that could have serious ramifications. And so other things that we've seen are outright, questionable behaviors in addition to just misconfigurations. So I talked about this almost a year ago at an OWASP event, right, yeah, in the before times. We had just published a paper where we had used our instrumentation to uncover side channels that were being exploited. So another situation where it's likely that, because the side channels were being exploited in SDK code, the app developer probably had no idea that certain types of data were being collected. And so to illustrate what I mean by a side channel, you have a security mechanism, in this case the Android permission system, which protects certain data from being accessed by the app. It regulates it, and obviously if that data can be accessed in some other way outside of that security mechanism, in this case outside of the permission system, then that side channel renders the security mechanism useless. Covert channels are similar, where you can have two colluding apps that work to get around the security mechanism, but I'm not going to go into that. So we built this pipeline where we can just do queries on our data to see, of the apps that we run, since we have both the data that they access on the phone through the permission checks, as well as the data that they transmit from the deep packet inspection that we do. And so then we can see which apps were sending data that they didn't have access, authority to access. And so, to give an example of how that looks, you have, for instance, apps that don't have the location permission, and then you have a set of apps that transmit location data. A reasonable person would think that these two sets are disjoint, but that's not in fact the case. We found over 1,000 apps that were transmitting location data when they didn't have the permission to. In a small number of these cases, we observed that this was due to GeoIP lookups that were far more accurate than we had expected. So GeoIP lookups, with a high degree of precision, but in many other cases, it was due to location being accessed in other ways. And so one way was just accessing the proc file system. So we observed that when going through the Android Java middleware that does the permission checks, that regulates access to many of these resources, but there are other ways outside of the Java part of it to access the same data. One is looking at the file system. So the proc file system is a virtual file system which has lots of potentially sensitive information that could be used to reveal private information about the user, such as location data. In this case, the MAC address of the upstream Wi-Fi router could be used to infer location data, and that's present in the ARP table, which is on the proc file system. And so, here's an example of an SDK. This is OpenX. It does a permission check. It calls the Java function for is permission granted to see whether it has access Wi-Fi state, which is one of the permissions that's necessary to get the BSS ID. And then failing that, it calls this function get device MAC addresses from ARP, which opens ProcNet ARP and just reads it from there, having been denied permission to get it the proper way. We found that this method was pretty common. I talked about this at length before. There are literally billions of people that have apps that are doing this. Other ways, though, that we found are similar in nature. So there's looking at the file system, but there's also running shell commands. So outside of Java, doing an exec. So we found pulling up IP or even ifconfig were unprotected, and so you can get things like Wi-Fi MAC address, routing information, other stuff like that. And so that's part of the reason why we instrument the kernel now, so that we can just look at all execs and all file opens to capture that sort of thing. Another one is here was another vulnerability that this was a lot more recent. We just got a CVE for this. I think it was last month. So there's a Java callback that basically you can register this callback to see when the network state has changed. So for instance, whether the user gains Wi-Fi access or loses Wi-Fi access. It turns out, though, as a optional field in the data that's returned, it included the Wi-Fi SSID without actually conducting a permission check. And so we found one app that was actually making use of this. So the CNN app, we observed transmitting the Wi-Fi SSID without holding the requisite permission. And it was sending that to 2 different third parties. And that was a result of getting it from this unprotected callback. And so again, the point is that, a lot of this, all involves, data flowing to third-party services, which in many cases, developers might not even be aware of. And therefore, this is a pretty complicated issue for compliance. What does this actually mean? What should we do about this? Well, or why is this even important? Well, in some cases, in addition to, if you're not developing an app for kids, or maybe your consumers aren't in California, this still has, consequences for you. So having, a privacy policy that doesn't necessarily match what your app actually does with the data could still get you in hot water. So here's a screenshot of the Weather Channel app as of, I believe, 2 years ago. And it says, this is a precursor to the permission prompt. It says that, it's about to ask for location. It says that, using location allows us to provide you with faster, more accurate weather. Well, in this case, it's a alleged lie of omission in that it didn't disclose that same location data was going to be used for ad targeting purposes and sold to several different third parties. And so misrepresentations like this could be illegal under various state laws about about not having deceptive practices, as well as the FTC Act, which has a similar prohibition on deceptive practices. And so saying data will be used for one thing, even if you legitimately believe that, and then having it used for something else could create problems here. And so, in fact, the Weather Channel was, sued for this by the LA city attorney. I think that actually settled this year. But, these are more of the issues, to think about. I guess I've already said this. And so what do you do here? What's the solution? I mean, really, if you're an app developer, basically, the takeaway here is, you should make sure that you're reading all of the SDK documentation for third-party SDKs that you're bundling into your code, regardless of whether or not you think it's relevant. You might bundle, a particular SDK because you want some function from it, and you read the documentation for that one particular function. But it's possible it's doing other things and other things that could have, consequences for compliance. The other thing is just making compliance people aware. So in your organization, you probably have lawyers whose job it is to be aware of these types of issues. They can't really be aware of these issues if they don't have a full accounting of all of the third-party code that you're integrating, so that they can look at the documentation to try and figure out whether they have, additional obligations. And then testing. So, again, we find all of this stuff by just running lots of apps and testing them to see if the observed behaviors match, the disclosures and, basically whether they match disclosures and their obligations under various laws. there's no real way around that. Just running the app to see what it does, what gets sent in the traffic and who that traffic is going to. And I guess with that, I'll leave it at, yeah, I'll just leave it there. So questions. Trying to find the other window. If you have questions, put them in the chat.
We have our first question.
Is there a cheat sheet for those of us developing SDKs? No, unfortunately. I mean, that's the problem, is that, well, I guess, I mean, well, the answer is no. That's why this is a complicated problem. Yo, that's a good question. So how do you handle scenarios where data being collected is encrypted? What we're doing, I wish I had actually had time to put a couple slides on this into this talk. Yeah, we find in many cases there's data being encrypted. Sometimes, you know, we're unsure of the reason. So like, you know, in some cases we see things like identifiers that are hashed that are transmitted. And, you know, maybe it's that the person who decided to do that thought that that meant it's, you know, more secure or is preserving privacy in some, you know, in some way. But there are services that that reverse hashes on exactly those types of identifiers, and so that doesn't really do a whole lot unless it's, you know, salted. In terms of, you know, in terms of, we've also seen some pretty interesting encryption. So one of the mechanisms that we use is, since we can see, you know, all the traffic coming off of the device, we can see the things that look like encryption or look like, you know, obfuscation somehow. And then we flag those for manual analysis. And then we have a whole series of filters that we write. And basically that, you know, it's based on each endpoint. So we see some endpoints that will have obfuscations that they apply. I think I talked about some of this when I gave a talk in January, some of the more interesting obfuscations. So there was the one in particular, which we've been referring to as the 46 ESAB method, where we saw traffic where it was base 64, but then reversed completely. And I mean, there are proper ways of securing data. This isn't one of them, and it's interesting, some of the different things that we've seen like that. I guess do I recommend using Pi-hole? I actually haven't used Pi-hole at all, so I can't really speak to that. The follow-up, so indicators of bad behavior when we build SDKs. The problem with, you know, indicators of bad behavior is it's all kind of context dependent. I mean, how are you defining bad behavior? Let me just unmute.
Oh, sorry. It's Blaze. I think I was just referring to some of the anti-patterns that you've discussed.
Yeah.
That kind of thing.
I mean, if you're, I mean, building the SDKs, I mean, I mean, one of the basic, I guess, one of the anti-patterns is if if you're denied the data through the permission system, you know, requesting it by exploiting a side channel, you know, by actually exploiting a vulnerability in the OS, that's a thing you probably shouldn't be doing. But that seems to be pretty common. I mean, I think that that's something that you could probably audit, right? If you could look at what's, even without having, building, I'm not saying that you build a custom version of Android so that you can debug your own SDK, but, what you could do is see, what data is being transmitted by it to, to various endpoints. And then you can just review what permissions were granted to see if that aligns. The documentation for what permissions protect which functions is available, and so basically doing some sanity checks against that. I mean, that's how we found a lot of these a lot of the side channels is just doing queries about things that we didn't think should be occurring, like apps transmitting location data without location permissions, stuff like that. And if it's your own app, it's obviously a lot easier to do things like that.
Oh yeah, in this case, it would be our own app, but of course, the development team's fairly large, and we just want to make sure that we don't inadvertently do something, in other words, it's not an adversarial situation. It's just more a kind of a good housekeeping and trying to do the best possible job. Yeah,
no, I mean, I think that just having periodic audits of what's in the traffic that you're sending, not just, is it contacting these endpoints, but, is it actually in the traffic? I've seen this before, actually as part of lawsuits where, the developer said, but we tested it. Here's some, here's some logs from Charles Proxy when we tested our app. The problem is that is actually where you get into some of the obfuscation stuff, like, custom, encryption that's occurring on top of TLS, where we did decrypt the TLS traffic and see there are a whole bunch of fields that look like encrypted or text or data that are present, and that's usually when we identify something as needing some binary archaeology to figure out what it's actually putting into that field. For your own app, I think it's just looking at the at the traffic and auditing to make sure that the things that it contains are things that you're expecting.
I also wonder, like, looking at the AST, like, I'm thinking of ways that we can automate some of this. Would that be like a useful, in other words, just having something that might scan the structure of the artifacts? Like
the problem is there's so much of this that happens dynamically, from determining which endpoints to contact and what data to send them based on, say, configurations received from another server at runtime, that just doing static analysis is really insufficient. And I think that that's probably a big pitfall that I think that is a really common pitfall right now, is that there are automated tools to like scan for things like that, but they're just incomplete because so much of this is dynamic. And especially because you're dealing with lots of intermediaries who are passing the data along along the way.
Like Cambridge Analytica, for example.
No, I wasn't even thinking about that, but I'm just thinking about like the mediation example where you have say multiple ad networks, and they're being you have they're your accounts, and you're getting the ad revenue from those ad networks, but the settings are being managed by some other third party mediator, and if they screw that up, you're liable then. And that's that's a big deal.
So just I'm putting on a little bit of a speculative hat here, because one of the I happen to work for a company that I guess provides a technology or a method for storing data or fields that might be sensitive. So I'm wondering if it would make sense for us to, like, if we had it's similar to like a tokenization strategy where the strings that get passed on the wire are in and of themselves without value, but they can be used to look up the real data. Maybe we should look at deploying some of that into this as well.
Yeah, potentially. I mean, I think that's the second step. I think the first step is, is answering, is it necessary that we send this data to begin with? And I mean, I think because too often that question isn't asked.
Okay.
Like, in many cases, and I've seen this many times where, there'll be a flag that gets sent to say, ignore the rest of the data that we're sending you. And that seems like that's a fundamental privacy design, failure, right?
Sure.
If you're sending a flag back to the server to say, ignore the data that I'm going to continue to send you. That's not how it should be. It should be done. When the SDK decides it's going to send that flag, it should also decide to then not send the data. And that's pretty common. So like that's how on Android the limit ad tracking flag. Now, like this is the big difference, that between iOS and Android that people are up in arms about now is not sending the ad ID. So before it was sending the ad ID, not sending the ad ID when limit tracking is set. On Android, what happens when limit ad tracking is set? It just sends another flag saying limit ad tracking is set, but the same identifier also gets sent, and so it's up to the recipient on their honor to honor that flag and ignore the identifier that they're receiving. And I think that fixing that issue of just only sending data that's necessary, that's kind of the prerequisite to then the subsequent question of, well, okay, how do we send the data that we need to send securely?
Right. Thank you.
Yeah, no, good questions.
I guess I'm just curious, just to sort of follow up on this again, are there geographies or regions, like for example, I'm thinking of like Europe and GDPR, are there communities or regions where there might already be like some leadership in this area, or constraints that we might need to be aware of?
I need to, I actually need to think about that. I mean, like, under GDPR, there's been a lot of, complaint about the lack of enforcement now that,
Okay.
It's existed for almost 2.5, it's been in effect for almost 2.5 years. And, it seems very similar to like the COPPA work where, like this has existed for a bunch of years now, but it's kind of amazing that, the apparent violations are rampant. And that seems to be entirely due to a lack of enforcement. I don't know if and when that's going to change. I mean, I think there's, obviously here in California, that's changing with, CCPA and CCPA might, it might go the same way, but it does look like now with CPRA that there are going to be, there's going to be a ramp up of enforcement. And I think also, better guidance being issued. I think that, since there's going to be a whole separate agency for that enforcement, I imagine they'll be releasing, better guidance for companies to stay in compliance. But I don't know. That's all speculative. There seems to be genuinely more focus here now, and so it seems like there's opportunity, but yeah, hard to say.
I was wondering if you could say a little bit more about recommendations for evaluating whether the apps that we're using, that we're including in our services, are sending along data that we intentionally send them to someone else where we don't want it to go. That's sort of the middle, yeah.
That's a really tough problem, and like I don't have answers to that. I mean, so I assume the issue you're talking about is like the app sends data to them and then they reshare it, afterwards.
Yeah.
I mean, like, technologically, that's not really something that we can handle, right? Because that, once it leaves their server, well, I mean, once it's received by their servers, that's the point where we can no longer see anymore what they're doing with it. And really all you have to go on are, contracts, terms of service, and privacy policies. And that's why it's it is often a leap of faith that everyone else is working correctly, even if maybe you've done your due diligence. Yeah, that's a big problem.
And then with the situation you described with like AdMob, where you found something that sounded to me like it was in that genre, was that by looking at their source code?
It was both looking at, well, it was looking at the, yes, both through it was looking at the various different components. So looking at the Facebook SDK and as well as the AdMob mediation. And then looking at the app to see how it had configured AdMob. Any other questions?
Maybe more of a comment on the previous question. I've heard of companies that are actually one of the things they're doing to detect the data being shared downstream is putting some kind of canary tokens in them, and then when they do threat intelligence and they see some data leaks, password leaks and things like that, if they find their unique user IDs somewhere, they kind of know the source and they know that they don't know the details, but they know something got wrong.
Yeah, that method has been in existence for a while. I actually encountered that. I first learned about that when, as part of a totally unrelated research project, we were looking at data brokers and we're buying lists. We bought a couple lists from data brokers, and I learned that it's pretty common practice for data brokers to put in fake names and addresses in there so that they can detect when their data is leaked. So I don't doubt that that's possible, that's happening here as well. But again, it's also kind of that's not a great mechanism, because it requires it comes down to a bit of getting lucky.
Yeah, no, definitely, it's kind of too late at that point, but at least you can review them with your vendor and maybe change vendor after the fact.
Yeah. Okay.
I'll read one that might be quick or might be hours long from chat that Roy posted. How do we learn more about this topic regarding user privacy and tracking?
Oh, that's a good question. What part do you want to learn more about? I mean, the tracking ecosystem generally? I need to think about this. I should put together some references. I can email a list of references if that's helpful.
Yay, my meeting just got canceled. If anyone's interested, by the way, just as a science project in playing around with like stashing sensitive fields in logs or traffic, I'm happy to help. I've got some friends in low places. I'm thinking primarily of like people doing like medical trials or stuff that might be subject to like HIPAA or PCI regulation, because our infrastructure has like special paperwork for that. So, it's just a thought.
Okay, well, I need to get going.
I'll be following you on Twitter for sure. I don't know if that's a useful feed or not, but do you do much with Twitter?
Yeah, it's probably equal parts sharing research and then me complaining about random things.
Oh, okay, same here. Yeah. Thank you.
Okay, cool.
Okay, well, thanks everyone for joining us today, and thanks Serge for a great talk. I believe Prashant will be publishing this talk on the OWASP YouTube channel. Thanks again, and everyone have a great weekend.
As I was giving it, there's a glaring typo on the title slide, so hopefully I'll have an opportunity to fix that.
Sure. Thanks very much, everyone.
Thanks for coming.